is triangle PQR. According to the question, we have to construct the triangle based on ASA congruence criteria. Therefore, with the help of B corresponds to Q and A corresponds to R, we will construct angle Q with an equal measure of angle B and angle R with an equal measure of angle A. Step 4. With B as the center, construct an arc intersecting the line BA and BC at points D and E. Without changing the compass setting, with Q as center, draw an arc which cuts the line QR at a point S. Set the compass to the length of arc DE. Using the same radius and with S as center, draw another arc which cuts the previous arc at point T. Next, we will join Q and T to form ray QT. Can you tell me how we will construct angle R? Pause the video and think about it. Let's understand this. In step 5, to construct angle R with A as center, we will draw an arc intersecting the line AB and AC at points F and G. Using the same radius and with R as center, draw an arc which cuts line QR at point U. Set the compass to the length of arc FG. Without changing the compass setting, with U as center, draw another arc which cuts the previous arc at point V. Next, we join points R and V to form a ray RV. Step 6. We observe that the two rays, ray QT and ray RV, intersect at a point. This point of intersection of the two rays is vertex P. Thus, we have triangle PQR, which is congruent to triangle CBA under the ASA congruence criteria. Today we saw examples based on how to construct a triangle when the measurement of two angles and the length of the side included between them are known.
Today we will learn the construction of a right-angled triangle when the length of one of its legs and hypotenuse is given. You might recall that if the hypotenuse and one side of a right-angled triangle is equal to the hypotenuse and one side of another triangle respectively, then both the triangles are congruent. This rule of congruency is also known as the RHS congruency criterion. So far, we have learned the construction of triangles based on SSS criterion, SAS criterion, and ASA criterion. Now, we will construct a triangle based on the RHS criterion. Suppose we have to construct a right-angled triangle ABC. In ABC, the measure of angle B is 90 degree, the length of the hypotenuse AC is 5.7 cm and the length of the side BC is 4.5 cm. Let us construct a triangle ABC with the given measurements. Step 1. First of all, we will draw a rough figure of triangle ABC with the given measurements and mark the given measurements on it. Drawing a rough figure gives us an idea of how a triangle can be formed. Step 2. Here, the length of the side BC is 4.5 cm. Therefore, we will draw a line segment of length 4.5 cm with the help of a ruler. We will name this line segment BC. This line segment is the side BC of triangle ABC. Step 3. Since angle B measures 90 degree, we will draw a ray BX which is perpendicular to the line segment BC at point B. We can construct this by marking a point at 90 degree using the protractor and draw a ray BX passing through it. Where should the point A be situated on the ray BX? Can you tell how to find the position of the point A? Think for a while. You got it right. We know that hypotenuse AC is equal to 5.7 cm. Let's get the position of the point A with the help of this. Step 4. The length of the hypotenuse AC is 5.7 cm. This means that the vertex A is at a distance of 5.7 cm from the vertex C. So, to determine the position of the vertex A on ray BX, we will measure a radius of 5.7 cm on the compass and draw an arc on the ray BX with point C as the center. Step 5. The arc intersects the ray BX at a point. The point of intersection is the point A. Therefore, now we will join the vertex A and the vertex C, from which we will get side AC of triangle ABC. In this way, we have completed the construction of triangle ABC, in which the measure of angle B is 90 degree, the length of the hypotenuse AC is 5.7 cm and the length of the side BC is 4.5 cm. Similarly, if we construct a triangle RPQ, in which angle P is equal to angle B is equal to 90 degree, hypotenuse RQ is equal to AC is equal to 5.7 cm and the side PQ is equal to BC is equal to 4.5 cm, then the obtained triangle RPQ will be congruent to triangle ABC. That is, if we place triangle RPQ on triangle ABC, then we will be able to see that triangle RPQ covers the triangle ABC completely. That is, both the triangles are of the same size and shape, which means triangle RPQ and triangle ABC are congruent. Thus, we can say that by using the RHS criterion, we get a unique triangle. So today we learned the construction of a right-angled triangle when the length of one of its legs and the length of its hypotenuse is given. In the next video, we will see some examples related to this. Today we will see some examples related to the construction of a right-angled triangle when the length of its one leg and hypotenuse is known. Triangle BCD is a right-angled triangle in which angle C is equal to 90 degree, side CD is equal to 4 cm and side BD is equal to 7.2 cm. Construct triangle BCD. Here, we have to construct triangle BCD. In triangle BCD, the measure of angle C is 90 degree, the length of the side CD is 4 cm and the length of the side BD is 7.2 cm. Now, we will construct triangle BCD. Step 1. First of all, with the given measurements of triangle BCD, we will draw a rough figure. We will mark the given measurements as well as the right angle. From the rough figure, we come to know that in triangle BCD, the side CD is the leg and the side BD is the hypotenuse. So, let's construct triangle BCD with this information. Step 2. As is given in the question, the length of the side CD is 4 cm. So, with the help of a ruler, we will draw a 4 cm long line segment. This line segment is the side CD of triangle BCD. Step 3. The measure of angle C is 90 degree and to draw an angle of 90 degree, we will draw a perpendicular line from the vertex C on the side CD as ray CG. To draw a perpendicular, we can take the help of a protractor or we can also use a ruler and a compass. the vertex B of triangle BCD should be located somewhere on this perpendicular. Step 4. We are given the length of side BD as 7.2 cm. Means vertex D is at 7.2 cm distance from vertex B. Vertex B must be present somewhere on perpendicular GC. Therefore, we will take a radius of 7.2 cm in the compass and draw an arc taking vertex D as center, which will intersect perpendicular ray GC at one point. This intersection point is vertex B of triangle BCD. Step 5. Now, we will join the vertex B and the vertex D, from which we will get the side BD of triangle BCD. In this way, we have constructed the right-angled triangle BCD. Example 2. In triangle EFG, angle F is equal to 90 degree and the length of each side other than the hypotenuse is 5 cm. What type of triangle is triangle EFG? Construct triangle EFG. In triangle EFG, the measure of angle F is 90 degree. That is, angle F is a right angle. Since in triangle EFG one angle is a right angle, therefore on the basis of angles, we can say that triangle EFG is a right angle triangle. Since in this triangle, apart from the hypotenuse, the other two sides are equal in length, we can say that it is an isosceles right angle triangle. Now let's construct triangle EFG. Step 1. First of all, with the help of the measurements given, we will draw a rough figure of triangle EFG. From this, we come to know that in triangle EFG, the side EF and the side FG are the legs and the side EG is the hypotenuse. Let's construct the triangle. Step 2. Using a ruler, we will draw a line segment FG of length 5 cm. The line segment FG is the side of triangle EFG. Step 3. With the help of a protractor, we will mark an angle of 90 degree on the vertex F, from which we will get a perpendicular ray FD on the side FG. The vertex E should be situated somewhere on the ray FD. Step 4. We know that the length of the side EF of triangle EFG is also 5 cm. That is, the vertex F is at a distance of 5 cm from the vertex E. Therefore, we will take a radius of 5 cm on the compass and taking the vertex F as the center, draw an arc on the line FD. The point of intersection is the vertex E. Step 5. Now, by joining the vertices E and G, we complete the construction of triangle EFG. So, today we saw some examples related to the construction of a right-angled triangle when the length of its one leg and its hypotenuse is known. In the next video, we will see one more example related to it. Today we will see another interesting example related to the construction of a right-angled triangle when the length of its one leg and the hypotenuse is known. Let's look at an example for this. Raj walked 10 steps in the northeast direction, then moved 6 steps towards south and then returned to the starting point. While walking, all of Raj's steps were equal in length. Find out which figure can be constructed for the given situation. First of all, we will make a rough figure and find out which figure we will get. For this, we need to know about the directions. So, let's understand them first. You must recall that there are 4 major directions: east, west, north, and south. With this, the directions in between them are the northeast, northwest, southwest, and southeast, which we depict as given in this figure. So now, let's solve our questions with the understanding of the directions. We will mark the location of Raj with the point P. Raj walked 10 steps towards the northeast direction. Suppose 1 step is equal to 1 centimeter. We will show this by drawing the line segment PQ in the northeast direction. Then, Raj walked 6 steps towards the south. We will show this by drawing the line segment QR towards the south. And then, Raj returned to the starting point. We will show this by joining the points P and R to obtain the line segment PR. We see that we have obtained a triangle. Therefore, we can say that a triangle will be formed in the given situation. On the basis of the angles, can you tell the type of a triangle that is formed? Think for a while. Let me tell you. We see that point P is in the west direction from point R and point Q is in the north direction. This means that the side PR and the side QR form a right angle with each other. That is, triangle PQR is a right angle triangle. Since triangle PQR is a right angle triangle in which angle R is a right angle, we can say that in triangle PQR, the side PQ is the hypotenuse and the sides QR and PR are the legs. If we use the given measurements, we can say that hypotenuse PQ is equal to 10 steps is equal to 10 centimeter and the side QR is equal to 6 steps is equal to 6 centimeter. Since we know the measurement of the hypotenuse and a side of a right-angled triangle, we can construct a unique triangle using the RHS criterion. So, let us construct a right-angled triangle, triangle PQR. Step 1. We have drawn a rough figure of triangle PQR already. Keeping this in view, we will construct triangle PQR. Step 2. Now, with the help of a ruler, we will draw the side QR of length 6 cm of the same measurement as triangle PQR. In this video, we are drawing the side QR in the vertical direction. But it is not necessary to do so. You can also draw it in the horizontal direction. Step 3. Now, we will draw a perpendicular RS on the side QR which passes through the point R. Vertex P must be located somewhere on this perpendicular. Step 4. To find the location of the vertex P, we will take a measure of 10 cm on the compass and draw an arc by placing the sharp edge of the compass on the point Q, cutting the ray RS. The point of intersection is the vertex P of triangle PQR. Step 5. Then, by joining the vertex P to the point Q, draw the hypotenuse PQ of triangle PQR. This will complete the construction of triangle PQR. Today we saw another interesting example related to the construction of a right-angled triangle when the length of its one leg and the hypotenuse is known.
Today we will learn how to construct a triangle when the lengths of two sides and the measure of the angle between them are known. Rahul has to construct a triangle ABC. In triangle ABC, we are given that the length of the side AB is 2.7 cm, the length of side BC is 4.7 cm and the angle B measures 65 degree. Rahul knows how to construct a triangle based on the SSS criterion. Under the SSS criterion, the length of all three sides of a triangle must be known in order to construct a triangle. Here, Rahul knows the length of sides AB and BC of triangle ABC, but he doesn't know the length of side CA. As a result, Rahul failed to construct a triangle ABC.
So tell me, could Rahul construct a triangle ABC using the information provided? Let's see. In the chapter Congruence of Triangles, we learned that two sides and the angle included between them of a triangle are equal to two corresponding sides and the angle included between them of another triangle, then the triangles are congruent. This rule of congruence of triangles is called the SAS congruence criterion. This rule also informs us that if two sides and the angle included between them are given, then we can construct a unique triangle. Let's construct triangle ABC based on SAS criterion. Step 1. First, we draw a rough diagram with the given measures. This helps us to determine the procedure in construction. In this way, we will be able to construct the triangle easily. Step 2. Next, draw a line segment BC of length 4.7 cm. Step 3. Here we have sides BC and AB and the angle B measuring 65 degree included between them. With B as the center, draw an angle of 65 degree with the help of a protractor. Draw a ray at point B. We will label the ray BD. The ray BD makes an angle of 65 degree with the line segment BC. The point A must be somewhere on this ray of the angle and we have to determine the exact location of point A on ray BD. Step 4. The length of AB has been given as 2.7 cm. Thus, point B is at a distance of 2.7 cm from point A. With B as the center, draw an arc on ray BD of radius 2.7 cm. The arc cuts ray BD at a point. This point of intersection is the vertex A of triangle ABC. Step 5. Join points C and A to get the third side of the triangle ABC, that is CA. Thus, we obtained triangle ABC using the SAS congruence criterion. Today we learned how to construct a triangle when the lengths of two sides and the measure of the angle between them are known. In the next video, we will see some examples related to it.
Speed, movement and time. Hello friends, can you feel that the earth is moving? But you are standing where you were. We know that the speed of some vehicles on the road is slow and some fast. But what is speed? When all of you get up in the morning, go to school, eat food, study, I'm sure you look at me because I tell you the time. Let us find out through this video the relationship between speed, motion and time. The objectives of this video: A. To gather information about speed and movement. B. To understand the relation between speed and time.
Ram, you have to take part in a race in the nearby village school tomorrow. Hurry up and sleep, otherwise you will not be able to wake up in the morning.
Oh, how does this watch come to know each morning that it is time to wake me up? It wakes me up at the correct time. Kaki, please call Shyam. We have to go early, otherwise the bus will leave.
Ram, Shyam has already left. Run and go. He must not have reached yet.
The bus will leave. Let me run and go. If I had an aeroplane, I would have reached early. Oh, the bus just left. Shyam is sitting in the bus. It is 7 a.m. Shyam will reach before me. The next bus will come in 10 minutes. It looks like I will get late. Shyam would have reached. Oh, the bus in which he left has reached now.
Hey Ram, you have already reached.
Yes, it is strange. I left in the bus which came after you left, but I reached before you.
I think your bus was faster than my bus.
The distance from our village to this village is 10 kilometers. I reached in 30 minutes and you took 40 minutes.
So it means that your bus took less time to cover a distance of 10 kilometers.
Yes, because my bus did not stop anywhere.
My bus also did not stop.
Friends,
The speed of the vehicles
moving fast is more. To find out which vehicle is moving at a faster speed, we will have to know the distance travelled by them in a particular time. The distance travelled by objects in a given time helps us in deciding this.
Are you ready for the race, Ram?
Ready, children? I'm going to begin the count from 3. 3, 2, 1.
Shyam, Mohan won the race. We have both come second.
It means that both of us ran at the same speed. Come, let us ask Sir, how much time did we take to complete the race?
Shyam and Ram, you took 4 minutes to complete the race, and Mohan took 3.2 minutes.
I want to know who was faster, Ram or me?
Children, whenever there is a race in your school, there is a starting point and an end point. The winner is the one who finishes this distance in the least time. To find out the speed of the object, we have to find how much distance it covers in a unit time. This is known as the speed of the vehicle. Therefore, you can find out the speed of a vehicle by finding out the distance it covered and the time taken to cover that distance. Therefore, speed is equal to distance divided by time. So if Shyam and Ram covered a distance of 100 meter in 4 minutes, then what was their speed?
Children, it is important to take part in a competition. Winning and losing is part of the game.
I think it was because of speed that I reached before you in the morning. Because the speed of my bus was more than the speed of your bus. We shall ask about the speed of the bus from the bus driver when we return home.
Look, Ram, what is this? Sand is falling down when I turn it upside down.
Children, this is an hourglass. When the ancient people did not have watches, they used this to find out the time.
It is so creditable, Shyam, that the people of the ancient times did not have watches, but they could tell the time by looking at the sunrise and sunset.
Nowadays, there are so many different types of watches. Like our coach had the stopwatch with the help of which he was noting the time we took in finishing the race.
Remember, we had read that the king of Jaipur had made the sun clock in Jantar Mantar.
It will be interesting to find out how the watches tell us the correct time.
We had studied that watches use the rotation motion, but the watches are so small, how is it possible for them to have the rotatory motion inside them?
Driver uncle, can you tell us the speed of the bus?
What happened, children? Do you have to reach somewhere quickly?
No, actually we want to understand about speed. We wanted to understand how much time will it take us to reach home.
Look, children, there is this device in vehicles which is known as speedometer. It tells us the speed the vehicle is moving at. Like the speed of this bus is 60 km per hour.
If the bus is moving at a speed of 60 km per hour, then how much distance is it covering in 1 minute?
Hey kids, let the driver brother drive the bus carefully. Tell me, how many minutes are there in 1 hour?
60 minutes.
And your question was, how much distance would the bus cover in a minute?
Didi, is 60 minutes to an hour. So if this bus is covering a distance of 60 km in an hour, it means that it will cover 1 km in 1 minute.
Correct answer. Do you know how the units are related to each other?
Didi, the basic unit of time is seconds and the big units are minutes and hours.
And what is the root unit of the speed? Didi, because speed is equal distance upon time, that's why meter per second is the basic unit of speed. Well done. And it is also expressed in other units, meter per minute or kilometer per hour.
Can you tell how many seconds are in a day and how many hours in a year?
I want to become a pilot when I grow up. The speed of plane is very fast.
And I want to grow up to become a mathematician.
And I am thinking that the speed of the rocket will be faster than the plane. I want to know more about this. Oh wow! Well done, children.
So friends, if a bus or a vehicle is moving slowly, then we say that its speed is less. And if the same vehicle is moving fast, then we say its speed is more. In this way, we can say that by the speed of the object, we get to know how slowly or fast an object is moving. Now we can define it in such a way that the distance travelled by the object in unit time is called the speed of the object, such as 60 km per hour, 10 meter per second, etc. See you, friends.
Nutrition in Animals, Part 1. Learning Objectives. 1. To understand what is digestion. 2. To understand digestive process in human beings. 3. To understand the journey of food from chewing to the stomach. Hello friends, how are all of you? On seeing me, I'm sure your mouth has started watering. I am the king of fruits, mango. I am indeed tasty, but I'm very nutritious too. My friends like apple, oranges, green vegetables, dal, chapati, milk, and I help to keep all of you healthy. But do you know that how are we digested? From tasting to digesting, we travel through a lot of parts of the digestive system. Come, let us understand the process of digestion with the help of this video.
Mother, I'm very hungry. The day in the school was hectic. We played and studied a lot. Please give something to eat soon.
Yes, mother. We really got tired today. Like vehicles need petrol to run fast, we will get energy from the food.
Wait for some time, children. I shall bring your food. Till then, eat this apple.
Yes, today our science teacher was telling us that fruits, green vegetables, milk is very important for our nutrition.
Is it? Please make Sonu also understand. He does not eat fruits. Isn't it, Sonu?
Friends, it is very important to eat fruits to be healthy. All of you should eat at least 3 to 4 fruits every day.
Do you know, Sonu, our teacher was telling us that we need a balanced diet. It should contain all the nutrients in appropriate amount, including water and roughage. Do you know the food that we eat cannot be digested in that form? Hence, it is converted to simpler form.
How?
This process is known as digestion.
Here, children, eat your food.
Wow, mother, this chutney is so delicious. Our tongue is so clever. It senses the different tastes easily, like sweet, sour, bitter.
Yes, you are right. Like when we think about golgappas, our mouth instantly starts watering. There are taste buds for different taste on our tongue, because of which we can sense the different tastes. There is a salivary gland which secretes saliva. It mixes with the food and helps to make it soft and helps us to gulp it easily.
How is my taste, friends? Sometimes sweet, sometimes sour.
We gulp the food like this and then it travels to our stomach and gives us energy. Digestion is an easy process.
No, Sonu, the process of digestion involves a long way. It begins with the buccal cavity till the anus. It is known as the alimentary canal.
What all parts are there in the alimentary canal?
Come, Sonu, let us draw a picture. I will tell you about the process of digestion through it. I have a test tomorrow about the same. It will help me revise too. Look here. The food we eat passes through this long tube which is known as the food pipe or the esophagus and reaches our stomach. The stomach and the various glands associated with the canal like the salivary gland, liver and pancreas help in secreting digestive juices. Come, now let us look at what happens to food in the various parts of the alimentary canal. The process of taking the food into the body is known as digestion.
Didi, there are 36 teeth in our mouth which help us to bite food into smaller pieces.
You are right, Sonu. We have different types of teeth which have different functions.
Yes, look Didi, these front teeth and the back teeth have different shapes.
Yes, Sonu. Look at this picture that I have made showing different types of teeth.
Wow, this is a very important information. Didi, sometimes when we eat food, we get hiccups and we also cough at times.
Shall I tell you another interesting thing, friends? Do you remember that few years back your teeth had started to fall? Because the first set of teeth are your milk teeth, which usually fall by the age of 8. The new set of teeth which come in place of them are permanent teeth.
Let me tell you, Sonu, when we eat food quickly or talk while eating, like you do, the food enters our windpipe, which is the reason we get hiccups and cough.
Now I shall be careful not to talk while eating food. Didi, what happens in the stomach after that?
The stomach is like a bag. It is the widest part of the alimentary canal. It is joined with the esophagus at one side and opens into the small intestine on the other.
What happens in the small intestine?
Let us first understand what happens in the stomach. The inner lining of the stomach secretes mucus, hydrochloric acid, and digestive juices. The digestive juices break down protein and fat into simpler substances. The acid kills the bacteria which enter with the food. It also makes the medium in the stomach acidic, which helps the digestive juices to act.
The food is completely changed till it reaches the stomach.
The food passes through a lot of paths ahead.
Didi, please tell me, where does the food go after the stomach?
Sonu, I will tell you about the journey of the food from the stomach to the other parts in the evening. Let us rest for some time now.
So friends, the food we eat passes through the alimentary canal. We have to pass through a long journey from ingestion to digestion. We learned through this video about the journey of food from the mouth to the stomach.
Today we will see some mistakes related to cube root. Mistake number 1. Some kids or students misunderstand the cube root sign and they end up dividing the given number by 3. Because of this, they get a wrong answer. Example, if they were asked to find the cube root of 27, then they would write it down like this. But then divide 27 by 3 to get the cube root. This gives them a wrong answer. To solve the cube root of 27, we do a prime factorization of the number 27. So that we express 27 as 3 into 3 into 3, that is in form of 3 cube. Since the cube of 3 is 27, on the contrary, we say that the cube root of 27 is 3. Hence, the correct answer is 3. Mistake number 2. Some children or students do not write the cube root sign correctly while determining the cube root of a number. Often they forget to write 3 in the front of the symbol of cube root or do not think it necessary to write. Like they write the cube root of 64 like this, which is wrong. This sign denotes square root. We should note that writing 3 is also essential in the cube root system of any number. From that we know that the given operation is to find the cube root, not the square root. Mistake number 3. Some children or students get confused between the words cube and cube root. Due to this confusion, if they are asked to determine the cube root, then they use the method of obtaining the cube. And if they are asked to determine the cube, they use the method of cube root. Often such mistakes occur while solving the question in haste. Such mistakes should be avoided. Today we saw some common mistakes related to cube root.
Today we will learn about cube and some interesting patterns related to them. In the previous session, we learned about power and base. We learned that if a number a is multiplied by itself m times, we represent this multiplication as a to the power of m. Now look at the number 8. If we multiply 2 3 times by itself, we get the number 8. Therefore, we can express 8 as 2 to the power of 3. We read this as cube of 2, which has the value 8. Here 8 is a number that is obtained by multiplying number 2 3 times by itself. We call such a number as cube number or a perfect cube. You must have also heard the term cube in geometry. Do you remember that if an object has 3 equal dimensions, that is, if the length, width, and height of a solid shape are equal, then we call it a cube. For example, a cube with 1 centimeter length, 1 centimeter width, and 1 centimeter height is shown here. Just imagine if you're given 8 cubes of 1 centimeter in length, 1 centimeter width, and 1 centimeter height. Can you make a big cube using them? Give it a try. Absolutely right. With this, you can make a complete cube. This is why we call 8 and all similar numbers as cubes. Now, try to answer this. Is 9 a cube number? You got it right. Here, we are getting 9 by multiplying 3 by itself only 2 times. So, we cannot call it a cube. Yes, if we multiply 3 one more time, then the number obtained is 27, which is a cube number. You can make a cube by using 27 cubes, which are 1 centimeter in height, 1 centimeter in length, and 1 centimeter in width, and establish that this number is a perfect cube. Cube of numbers from 1 to 20 are shown here. Try to learn them as they are very useful in mathematics. As you can see, the number 1 is an odd number, and if we look at its cube, that is also an odd number. Similarly, you can see that 2 is an even number and its cube is also an even number. Is this true for all numbers and their cubes? You can stop the video and find out. You will find that the cubes of even numbers are even and the cubes of odd numbers are odd. Similarly, you can also see that if the digits in the units place in a number is 0, 1, 4, 5, 6 or 9, then the digit in the units place of its cube is also the same. If the digit in the units place of the number is 2, then the digit in the units place of its cube is 8. And if the digit in the units place of the number is 8, then the digit in the units place of its cube is 2. Is this also true in terms of 3 and 7? Pause the video and find it for yourself. Now, you can now find out which digit will be in the units place of the cube of a number by looking at the digit in the units place of the number itself. Now let us learn how to find out if a number is a perfect cube or not. It is very easy. Suppose we have to find out whether 216 is a perfect cube or not. For this, we have to do prime factorization of 216. In this method, we divide the number by prime numbers until we get a prime number or 1. Like here, we will divide 216 by 2, 2, 2, 3, 3 and 3 respectively. Now we can write 216 as 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 3, which we can write as 2 to the power of 3 multiplied by 3 to the power of 3. There is also a rule in the laws of exponents: a to the power of m multiplied by b to the power of m is equal to a multiplied by b to the power of m. Using this rule, we can write 2 multiplied by 3 to the power of 3 here, which would mean 6 to the power of 3. Since we can write 216 as the cube of a whole number 6, 216 is a perfect cube. You should also understand one more point. If the power of all the prime factors of a number is 3 or a multiple of 3, that is, if we divide all the prime factors into groups of 3, only then that number will be a perfect cube. Now let's talk about 1372. Its prime factorization can be done in such a way that we know that 1372 is equal to 2 multiplied by 2 multiplied by 7 multiplied by 7 multiplied by 7, which we can write as 2 to the power of 2 multiplied by 7 to the power of 3. Now here we can see that the power of one factor is 3, but the power of the other is 2. Since the power of all factors is not 3, we cannot call 1372 a perfect cube. Can you tell what can we do to convert it into a perfect cube? Think for a while. Of course, we have to multiply 1372 by 2 to get the number 2744. So now the power of 2 becomes 3, and we can express the factors 2 to the power of 3 multiplied by 7 to the power of 3 as 2 multiplied by 7 to the power of 3, or 14 to the power of 3. Therefore, the number obtained 2744 is a perfect cube. Now look at the given pattern. Here you can see that the sum of consecutive odd numbers is a perfect cube. Isn't this interesting? Now proceed with this pattern by yourself. By now, you must have understood many interesting facts about cube. So today, we learned about cubes and some interesting patterns related to them. In the next video, we will see some more examples related to them. Today we will see some examples of cubes and their patterns. Is 27,783 a perfect cube? If not, which is the smallest natural number by which it should be multiplied to make it a perfect cube? Let's find out whether 27,783 is a perfect cube or not. For this, we have to do the prime factorization of 27,783. In this method, we divide the given number by prime numbers until we get a prime number or 1. Like here, we will divide 27,783 by 3, 3, 3, 3, 7, 7 and 7 respectively. Now we can write 27,783 as 3 multiplied by 3 multiplied by 3 multiplied by 3 multiplied by 7 multiplied by 7 multiplied by 7. Therefore, we can write this as 3 to the power of 3 multiplied by 3 multiplied by 7 to the power of 3. Is the power of all factors 3 here? No, here the power of one prime factor 3 is not 3. Since all prime factors of 27,783 do not have the power of 3, or all factors cannot be expressed as cubes, we can say that 27,783 is not a perfect cube. So can you guess which natural number do we have to multiply it with to make it a perfect cube? Think for a while. You got it. We have to multiply 3 multiplied by 3 with these factors so that we can express this 3 as 3 to the power of 3. So now we can write it as 3 to the power of 3 multiplied by 3 to the power of 3 multiplied by 7 to the power of 3. Since all factors are now represented as cubes, we can say that the number obtained from 27,783 multiplied by 3 into 3 will be a cube. That is, if we multiply 27,783 by 9, we get a perfect cube. Example 2. Is 1715 perfect cube? If not, which is the smallest natural number with which it should be divided to make it a perfect cube? First, let's find out if 1715 is a perfect cube or not. For this, we have to do prime factorization of 1715. In this method, we divide the number by prime numbers until we get a prime number or 1. Like here, we will divide 1715 by 5, 7, 7 and 7 respectively. Now we can write 1715 as 5 multiplied by 7 multiplied by 7 multiplied by 7. We can write this as 5 multiplied by 7 to the power of 3. As you can see, here the power of 7 is definitely 3, but the power of 5 is only 1. Since the power of all factors is not 3 or it is not a multiple of 3, we cannot call 1715 a perfect cube. If we remove 5 from the factors, we will get 7 to the power of 3, which is equal to 343, which is a perfect cube number. Can you find out how can we remove 5 out of the factors of 1715? Think for a while. Let me tell you. We have to divide 1715 by 5 so that we'll get a perfect cube number, 343. In this way, 5 is the smallest natural number which should divide 1715 in order to get a perfect cube number, that is 343. So today, we saw examples of cubes and their patterns. In the next video, we will see some misconceptions related to them. Today we will see some misconceptions related to cubes and their patterns. Misconception 1. Which of the following statements is correct? A lot of times, children do not have a proper understanding of the cube. In such a situation, they make various kinds of mistakes. For example, some children think that the cube of a number means adding that number 3 times. But this is a misunderstanding. The answer given with this understanding is option 1. This is an incorrect answer. Similarly, some children understand that the cube of a number means multiplying that number by 3. Children with this misconception will choose option 2 as an answer, which is also a wrong answer. Some children are unable to decide whether they have to multiply the number 3 times by itself or multiply 3 by itself as many times as given number. In such a situation, they give option 3 as the answer, which is a wrong answer. The correct understanding is that the cube of a number means multiplying that number 3 times by itself. With this understanding, the correct answer is option 4. Misconception 2. Which of the following statement is correct? Some children are unable to understand the exact meaning of exponents, due to which they make small mistakes in the context of the cube. Some children begin to believe that 18 to the power of 3 is equal to the sum of 10 to the power of 3 and 8 to the power of 3 because the sum of 10 and 8 is 18. But this is a misunderstanding. If we consider the left-hand side, 18 to the power 3 can be written as 18 multiplied by 18 multiplied by 18, which equals to 5832. Similarly, on the right-hand side, 10 to the power of 3, which equals to 10 multiplied by 10 multiplied by 10, is equal to 1000, and 8 to the power of 3 is equal to 8 multiplied by 8 multiplied by 8 is equal to 512. And if we add them both, we get 1512. Do you think both the sides are equal here? Here, 5832 is not equal to 1512. So both sides are not equal. This shows that the first statement is false. This cannot be the answer for the question. Some children think that a number can only be expressed as a cube of its prime factors. In option 2, 6 is not a prime factor. This can also be a reason that children think that the second statement is wrong and the first statement is correct. But this is a misunderstanding. That's why they feel the second option is wrong. Remember, we can write 18 to the power of 3 as follows. We can further factorize it using groups of 2 multiplied by 3. Since 2 multiplied by 3 is equal to 6, we can write it as 6 to the power of 3 multiplied by 3 to the power of 3. So now you must have understood that the second statement is correct and it is the correct answer to the given question. So today we saw some misconceptions related to cubes and their patterns.
Welcome all of you to this video. In this video, we will learn about the combination of solids and different perspectives of three-dimensional shapes. In the previous class, we learned about flat shapes and solid shapes. Raghav's father gave him some shapes and asked him to identify them. Can you identify these figures for Raghav and tell them their names? Pause the video to try yourself and then match your answer. Perfect! These shapes are rectangle, cylinder, cuboid, cube, triangle, circle, square, sphere and cone. Now Raghav's father shows him some more figures and asks if he can tell the names of the shapes. Raghav tells us that this is a dumbbell. It is a hut and it is something like a warehouse.
Well done. But these are the names of these things. Let me tell you about
shapes of these things. If you look at this dumbbell carefully, you will know that it is made with the combination 2 spheres and a cylinder. Similarly, this hut is made of a combination of cone and a cylinder.
Raghav. Now what can you tell about this warehouse?
Father, its lower part is a cylinder and the upper part
hemisphere.
Well done. You have learned very quickly. Come. Now let me tell you another important fact related to shapes. If you look at this box from above, what do you see?
I only see rectangle when viewed from above.
And what do you see from the front?
Looking from the front, I see a square.
And from the side view?
Looking from the side, I again see a rectangle.
Well done. The view that we get when we see an object from above is called top view.
The view that we obtain
when we see the object from the front, it is called front view.
The view that we obtain
when we see the object from the side is called side view.
When we see solid objects or three-dimensional shapes from different views in this way, we call it different perspective of three-dimensional shapes.
I hope you have understood everything that we have just seen.
Yes, Father.
In this video today, we learned about different perspectives of shapes and three-dimensional shapes made by combining plane shapes. In the next video, we will see some examples based on these. Welcome all of you to this video. In the previous video, we learned about shapes made from the combination of two-dimensional shapes, different perspective of three-dimensional shapes. Today, we will see examples based on these. Maya keeps her jewelry in the box shown. Can you tell by which combination of shapes has this box been made? As we can see, the base of the box is cuboid. Well done. But what shape is this lid of the box? Well done. This is half a cylinder. That's why Maya's jewelry box is made of a combination of cuboid and half cylinder. Let us now see another example. Identify the top view of the given solid, the front view and the side view. As you can see, the front view is a rectangle. Can you tell the side view? Well done. The side view is a triangle. Now the question is, what will be the upper view? Perfect. Looking at it from above, we will see a view of two connected rectangles. Today we understood solid shapes with the help of examples.
Today we will learn about direct proportion. Amit bought 2 chocolates for 20 rupees and Nisha bought 4 chocolates for 40 rupees. Can you tell whose chocolates were more costly? Think. Let me tell you, we can say that the ratio of the number of chocolates purchased by Amit and the number of chocolates purchased by Nisha is 2:4, that is 1:2. Similarly, the ratio of their values is 20:40, that is 1:2. This shows that as the number of chocolates has doubled, their values also doubled. In this way, the price of chocolate depends on their number. We can say that here the ratio of number of chocolates and the ratio of their values is the same. In this way, if two ratios are the same, then they are in proportion. To indicate equality in ratios, use this sign or this sign. On the basis of proportional relationship, we can say that the cost of chocolate was same for both Amit and Nisha. Many times we encounter situations such that if one quantity increases, the other also increases. For example, if the number of chocolate increases, their price also increases. But in each case, the ratio of number of chocolates and their prices will be same. If there is an increase in one quantity X in such a way that the others in such a way that there is no change in the ratio x by y, then we say that x and y are in direct proportion. In such case, x by y is constant. Let's consider this as k, where k is a positive number. v2 by y2 is equal to x3 by y3 and so on is equal to k. In such a situation, both the quantities where